let's start with some questions. So go ahead and pause here. I'll go over the answers after I cover the relevant sections. Blooming. Why bother with a T2 star or T2 gradient echo image when T2 spin echo images have more signal? The answer is that sometimes we're specifically interested in what's causing a loss of signal, like blood products. Consider the following two images, which demonstrate the principle of blooming. Hypointensity on T2 star that is specifically due to shortening of T2 prime. To identify blooming, the first step is to identify dark signal on the T2 star image. So which of these is the T2 star image? So to review, we know that they're both T2 weighted images because the white matter is dark relative to the gray matter. And we know that they're either T2 or T2 star weighted images because the CSF is bright relative to the white matter. In order to find the T2 star image, we just look for which image is grainier, essentially, and that's going to be this one. So there's the hypointensity on T2 star. So this hypointensity could be due to shortening of T2, shortening of T2 prime, or both. Because loss of phase coherence on a T2 star weighted image is due to both of those dephasing mechanisms, right? T2 is due to spin-spin energy transfer. There's nothing we can do to correct that. That's going to be present. T2 prime is something that we can correct. That's the inhomogeneity of the magnetic field, and that's something we can correct with the spin echo. But a T2 star weighted image does not have a spin echo to correct that. Therefore, we're sensitive to T2 prime effects, which is exactly what we're trying to detect in blooming. So the next step is to look at the same location on a T2 spin echo image. So we see that there's bright signal here. So that tells us that the hypointensity on T2 star can't be due to shortening of T2, because if there was shortening of T2, it would look dark on this T2 spin echo image. Therefore, the hypointensity on T2 star has to be due to shortening of T2 prime. So in this example, the blooming is likely due to blood products associated with a cavernous venous malformation, which is sometimes referred to as a cavernoma. What causes shortening of T2 prime, aka blooming? So in short, paramagnetic and diamagnetic substances. So paramagnetic substances, examples include blood products, metallic hardware, even air. And these have unpaired electrons associated with them, which can augment the local magnetic field, increasing magnetism locally. That's paramagnetism. Diamagnetism has to do with paired electrons and usually is not a significant contributor to changing the magnetic fields locally. However, if you have large calcifications that are clustered, that can cause an effect. So large calcifications can contribute to diamagnetism. Paramagnetism and significant diamagnetism disrupts the homogeneity of the local magnetic environment of protons, causing them to precess at different rates and lose phase coherence. So here's that wonderful diagram from Alan Elster again. So we're just showing the T2 prime related dephasing of the spins. And we're saying that that can be due to paramagnetic substances, things with unpaired electrons, like blood products, so that's deoxyhemoglobin, methemoglobin, hemosiderin, right? The iron in these has unpaired electrons and will augment the local magnetic field. Metallic hardware can cause massive blooming artifacts, and even air can do this. Diamagnetic substances, specifically large chunky calcifications, can also significantly disrupt the homogeneity of the magnetic field. So these are the things that we should be thinking about when we see blooming. So let's go over the answer to this question. This is basically the same case that I just went over, so we'll go quickly through it. So we see hypointensity on this T2 star weighted image. That could be due to shortening of T2 or shortening of T2 prime. In order to confirm that it's blooming, aka it's, or not aka, it's specifically due to shortening of T2 prime, we look at the corresponding location on a T2 spin echo image. If there's bright signal in there, that tells us that it wasn't due to shortening of T2, it had to be due to shortening of T2 prime, and that's blooming. Blooming is hypointensity on T2 star that's specifically due to disruption of the homogeneity of the local magnetic field. And again, that can be due to paramagnetic substance, like in this case, like blood products associated with a cavernoma. But it can also be due to diamagnetic substances like calcifications if they're big enough.